Now the last part of this chapter is called the first law of thermodynamics. So the first law of thermodynamics is given by this equation, delta U equals to delta Q plus delta W. But be aware that you cannot use the equation and call your delta as change, right? Change. So they want you to specifically mention the sign conventions as well. So what do we mean? Now delta U means supposedly in maths delta means change. So U is internal energy. So by right it should be change in internal energy. But we won't say change in internal energy, we will say increase in internal energy. Because change in internal energy could either be increase or decrease in internal energy. But the sign convention we're going to use is increase is positive, so we're going to say increase in internal energy. Similarly, delta Q is supposed to be change in heat, but we won't say change in heat, we will say heat absorbed by the system, because delta Q can represent either heat absorbed by the system or heat given out by the system. So the one that we use as a sign convention as positive is heat absorbed by the system, so we call it heat absorbed by the system. So similarly, delta W supposedly is you will call it a change in work, but here we will use work done on the system, because work done on is given the sign convention as positive, right? And work done by the system will be given a sign convention as negative. So it actually makes sense, because if you think about it, your delta U here, which is the increase in internal energy, would happen if the system absorbs heat, that means it gains energy, and then you do work on it, so it also gains your energy. So if it absorbs heat and you do work on it, so you will absorb energy, and so the internal energy will increase. So remember to define the first law of thermodynamics this way: increase in internal energy of system is equal to the heat absorbed by the system and work done on the system. All right. So let's look at the next part of this definition. If we look at the bottom part, it also says that the internal energy of a system depends only on its state, that is determined by the values of P, V, and T. It does not depend on the processes that are involved in reaching that state. So what it means is, for example, if you have an ideal gas and it has a certain value of P, V, and T, we will be able to calculate its internal energy, and it doesn't matter how the gas was produced, meaning to say what are the processes that the gas actually went through to arrive at that state. That doesn't depend how much internal energy it has. The amount of internal energy only depends on the values of P, V, and T.